We're going to talk about 3 types of research: descriptive research, correlational research, and experimental research. So descriptive research is describing how common something is or how often something occurs. Next, for correlational research, we're looking at the relationship between 2 measured variables. So if X changes, how does Y tend to change? And in those cases, we're understanding that relationship between those 2 variables, and we can use correlations to predict future outcomes. And then experimental research, that's when we start manipulating some of our variables to determine causality. If we manipulate X, how does Y change? So we'll start by talking about descriptive research, and this is when we're looking at one measured variable. So if we have descriptive methods, these are any means or methods that we can use to capture, report, record, or somehow describe a group. And so we're looking at some kind of measurement for that particular group. So we can use methods like naturalistic observation or participant observation. Case studies are a huge one for psychology. We might also have surveys, and these aren't, again, an exhaustive list of techniques, but these are some really useful ones that you'll often encounter. And we'll talk about each of those in a minute, but all of these conclusions would be based on a single measured variable. So here is the average happiness for students in their first year of undergraduate. Sometimes people will group descriptive research in with correlational research, and we'll see that correlational research looks at a relationship between 2 measured variables. So because both descriptive and correlational only work with measured variables, sometimes they get sort of squished together. But I like separating them out because of our 3 different sort of goals with psychology. That's why I'm considering them separately here. But they do both use measured variables, so they are similar to one another. So, what is naturalistic observation? This is when you're observing an individual's behavior without manipulating or controlling any variables in that environment. So you're going to their natural habitat and watching how they behave under normal conditions. So an example would be Jane Goodall going into the jungles to watch gorillas. And her practice actually brings up some of our considerations with naturalistic observation. When she first went in and sort of sat near the gorillas, they were worried about her. They weren't sure if she was a threat to the group. And so their behavior changed when she appeared. So we actually experienced something called reactivity, where they've adjusted their behavior so it's no longer natural. To get around this, she sat there and waited until they acclimatized or got used to her presence. And after a few weeks, once they knew she wasn't a threat, they resumed their normal behaviors. And then she started her observations. So you have to account for that reactivity. This is really useful because it gives us very representative understandings of the behavior in the real world. Issues being no control over behavior, the possibility for that reactivity. Related to that, you can also run into something called demand characteristics. And this is when people change their behavior because they're being observed. So specifically, they'll often change their behavior so that they're either behaving the way that they think they're supposed to behave, or maybe they're going to change their behavior so that they look better to the person who's observing them. An example of that would be you're driving along down one of the main streets and a police car pulls into the lane next to you. So it's 2 lanes, you're both going about the speed limit, but maybe you've slightly adjusted your posture. Maybe you now have both hands on the steering wheel, and maybe now you are certain that you are just under the speed limit, whereas before you might have been less concerned about that. But the appearance of somebody who might be watching and judging your behavior has caused you to adjust your behavior. So in that situation, those changes are demand characteristics. So that's one of those reasons why you might have to wait or try and hide the presence of the observer. So we do have some issues here. In addition to our demand characteristics and reactivity, we have no control over which behaviors happen and when. We are not able to sort of tell them to repeat a behavior and keep it natural. And it's also very difficult to determine exactly what it is that caused that behavior to occur. Did the gorilla get up because their legs are tired from sitting there, because they've picked up all the food in that area, or because they just want to go and hang out with somebody else? We can't be sure because we haven't controlled anything else in that environment. And another downside is this requires very long periods of observation. And especially when we're looking for very, very rare behaviors, you can spend long periods observing and not observe what it is that you're looking for. So for those rare and not often occurring behaviors, you might never end up seeing them. And if you see them once, they might never reoccur during your observation periods. So we have to keep those limitations in mind. Closely related to that is participant observation. And this is when our researcher would interact with our population of interest. So I guess go with my usual example, which is undercover shoppers. So these are people who are hired to pose as customers in stores, go in, pick up a few items, buy the items, and leave. But while doing so, they're evaluating things like, how did the staff treat me? What did the store look like? What was the purchasing process like? So the participants, these people who are involved in collecting that data, are taking on a role to get a feel for the situation from the inside. So you're going to become a member of a particular group, and you are then going to learn about how those individuals experience the world. So it gives you insight from those participants' perspective. Of course, we have limitations. Some of them are similar to what we already saw with naturalistic observation, but we can also add on that because our researchers are the ones doing the observations as part of this group, they're actually subject to their own biases and their own world experiences, their own opinions, their own mindsets can actually influence how they interpret what they're seeing. You could do things like, say, having a hidden camera so that the person experiencing it isn't the only person who's interpreting the experience, but that's not always possible. Once again, those observations may not be repeatable. We might not know what's causing those observations. You might not encounter rare behaviors, and so on and so forth. So we want to just keep those limitations in mind. Our next one are case studies. And while most of the time when we talk about a case study, we talk about a single individual who has experienced some extreme event that we can then use to study extensively to better understand something related to that extreme event. But technically, you can have a case study on a single group or on a single rare situation. Those aren't as often discussed in psychology, but they do technically count as case studies. And our benefits here is you get tons and tons of detail. The downsides being is that because it's just a single person or a single group or a single situation, you don't get to collect a ton of data. So if we're trying to run statistics, you can't run probabilistic statistics with a sample size of 1. So it means that we can't necessarily draw, say, causal relationships. We can't make big picture statements because we can only be sure that this is how this works for this individual or this situation. So we get a lot of information, a lot of detail, but because it's not an experiment, we haven't been able to control for things, we can't be certain about what's driving that finding. An example of this would be H.M., one of the most famous case studies with psychology, and I believe he'll come up at least once more. But H.M. Basically had very bad epilepsy, and to try and stop the seizures, they removed a bunch of these subcortical structures, including the hippocampus, which nowadays we know is related to memory. However, by removing all of those structures, yes, it stopped the seizures. It did also affect their memory, but it also removed some of the structures around the hippocampus. So until they had conducted other studies, other follow-ups, or had other case studies, they couldn't be certain if it was the hippocampus itself, or maybe the structures immediately around the hippocampus, or something else that had been affected by that surgery. So that's what we mean by not being certain of causality, at least until we have other data to draw from. And then my last point is our surveys. So like I said, questionnaires, surveys, similar in my mind. And these are questions that are designed to extract specific information from a group of individuals. So some of the benefits here is that these are fairly easy to administer, and you can administer them to very large groups. So you generate one of those Google polls where you have all these questions and people can select a bunch of responses, and you email it out to everyone in the mailing list of the department you're working with. And then you can collect however many people respond to that survey. Of course, we have our downsides for this, though. There's the potential for bias. Bias on the side of the researchers, because we might design or ask questions in a leading way or in an ambiguous way. And in those cases, we can influence responses and not necessarily in a good way. You can also have bias on the side of the participants, where maybe they want to make sure that they look good, or they don't want to admit that they engage in sort of frowned upon behaviors or whatever. So once again, we have that adjustment of behavior to match what they should do. Now that we've gone over some common ways to collect data or to do measurements when it comes to psychological research, next we're going to move on very, very briefly to talk about statistics. And most people immediately hear the word statistics and get really worried about how complicated this is going to be. But if we think about it, statistics is just a way for us to use mathematics to try and organize or summarize or interpret some kind of numerical data. So this is us taking all of those measurements we've done and making sense of them, or making them presentable to someone else so they can make sense of them. So we're going to focus on two types of statistics: descriptive statistics and inferential statistics. Now, from the section that we're already talking about, we can probably assume we're going to keep going with descriptive here for descriptive statistics, and we'll actually swing back for inferential statistics. However, descriptive statistics, in case we need to know, is just us organizing and summarizing the data that we've collected in some useful way. So once we start looking at this, you're going to think, well, that doesn't seem like statistics as I conceptualize it, mainly because all we're going to be doing is talking about the shape of the data that we have. Inferential statistics is what most people think about when we start interpreting that data and drawing conclusions by making some inferences. So we'll make some statements based on probability, which again will come up much later on. So with descriptive statistics, what's one of our main things that we look at? And these are measures of central tendency, basically asking, where's the middle of our data? Where's the center of all of the measurements that we took? And typically, when you think of finding a center point for reporting a single value for a collection of measurements, say we do our measurements of height, well, we probably report the average. So that is the mean. It's the center of our data set that we would collect by adding together all of our height measurements and dividing by the total number of measures that we took. The average is probably conceptually simple. You might also remember, probably from high school math, that we can also talk about the median and the mode, where the median is talking about the number that's right in the center. So if we take all of our height measurements and we put them in numerical order so that the lowest values are on one end of our sort of string of numbers and the highest value is on the high end, the farther end, then we would find the exact middle of all of those values. So if we had taken 9 height measurements, then our 5th highest value, the one right in the center, after putting it all in order, would be our median. If you end up having an even number, you have to take the middle two numbers, add them together and divide by 2. But still, we're looking for what is that number in the center if we put everything into numerical order. And then our mode is going to be the value that occurs most frequently. So how many people were measured to be 5'5"? If there are more people who are 5'5" than any other height measurement, then that would be our mode. And for those who are more visual individuals, we can actually look at these sort of overly simplified frequency distributions. So here on our vertical axis, on our y-axis, we'd have something like proportion of the population or total number of measures or something like that, some kind of quantity. So the higher they are away from here, so in that vertical, that means the more of the people that we measured or of the measures we have got that score. And then across the bottom, we would have whatever score it is that we're measuring. So we've been using height. So this could be the shortest to the tallest in terms of height, or it could be something like IQ, the lowest to the highest IQ score. And so we see that our mode is where that curve peaks. So that is the most people that got a particular score. What is that score? That's our mode. And so you'll find that that always falls right in the middle of our curve. If we look at our median, we're specifically dividing our measurements in half. So 50% of our measurements are lower than that median number, and 50% of our measurements will be higher than that median value. And this is a little bit different. You'll find it's shifted off to one side. So it's not sitting right at that peak. And that's because the median can be influenced by having a couple of values that are really high. Alternatively, we could have it shift the other way if we had a couple of values that were really low. But it just tells us that the median can be influenced by having outliers or very high or very low scores. And for our mean, we see here that this one has been shifted the farthest. So having those outliers, a couple of people with a really high score, has now dragged our average over. So you can actually think of it as our mode being unaffected by those outliers. It still stays right in the middle of that peak. The median is slightly affected simply by the fact that there are now a couple of extra sort of numbers at one end of our line. And then the mean is affected by the magnitude of those. So if you think about it, if we'll use IQ. If we had no outliers and our highest score was 150 for an IQ, which is very high, and then we had somebody else come in and they had 180, which I'm not even sure is possible, but that one value would now all of a sudden drag our mean upwards simply because it's so much larger than the other values. And we calculate the mean by adding those values together and dividing by the number of measures. So it's more affected. So you can think of those in sort of least to most affected by outliers. All right, so that tells us where the middle of our data is, but it doesn't necessarily tell us much about the shape of the data. So we can actually use another term called variability to describe how spread out our data is. So what is that shape of the curve that we're looking at? There's a couple of different ways that you might have seen this. You've probably heard the terms standard deviation and or variance. Those two are directly related to one another, where the standard deviation is the square root of the variance, or the variance is the standard deviation squared. And there are ways to calculate that out. That's just not something that we need for this class. But what that standard deviation or variance is telling us is basically how far our scores tend to be from that mean, from the average for our data. So a higher standard deviation means that our data points tend to be further away from the center, and a lower standard deviation means that they tend to be closer to our average score. We could also report a range, and there's a couple of ways you can do this. You could just talk about subtracting our lowest value from our highest value. So what is the difference between the tallest person and the shortest person in our data set? Or we could just state this was the lowest score and this was the highest score, and people can figure out how much space is between the two. Both describe the range fairly well. But all of this is just telling us, what is our distribution? What does our data look like? And if that doesn't quite work for you yet, I have two diagrams that help sort of clear this up a little bit. So on this diagram, we have IQ scores. And again, it's a frequency diagram. So this is just the number of people that we sampled with this IQ. There's no units because we don't really care. But they both have the same average, which any IQ score or any IQ test will have an average of 100 in a population it's been designed for. But we see that our male curve, so the purple line here, is a little bit wider than the women's curve, the female curve. And what that means is that that purple curve would have a larger standard deviation, telling us that the data points are more spread out away from that middle point, away from that average. Whereas the female orange curve has a lower standard deviation because it is closer to that average. It is nearer that mean. And we can even see that the range would be different between the two because our highest and lowest scores aren't the same either. And as once again, we don't need to calculate those values. We just need to understand how they would change depending on the shape of our data. And continuing with that shape of our data discussion, we were looking at positively skewed data on this slide here. But if we go with our nice clean lines, we can see that they've shown we have our mode, median, and mean least to most affected by those outliers. The way that I like to think about this, to conceptualize it, is if we have a normal distribution, which for statistics has a specific definition and a specific understanding, and it's very important. But for us, we just care that it's symmetrical. That means that we're going to have our mean, median, and mode are all the same value. So with no outliers, they're all equal. So you'd only really need to report one of them. That the three different options really only matters with skewed data. But if we think about it, if they're all starting as a normal distribution, and if we add one really high score to that normal distribution, then our curve looks more like this, where the tail points towards those outliers. So it is positively skewed because we have extra very high or very positive scores. Conversely, our negative skew happens if we had added some low scores that are more extreme. And so here we see that that points off towards those very low scores or those negative scores, meaning the data is negatively skewed. And you'll find that those different median or central tendencies get dragged now in the opposite direction, pulled by those outliers. So hopefully that helps sort of understand conceptually what's happening with those different central tendencies depending on the shape of our data. And that's all we needed for our descriptive statistics. So as promised, not super complicated quite yet. So with our wrap up here to talk about our descriptive research, what are some pros and cons? These shouldn't be super surprising. Pros, we're detecting and describing variables of interest. So here are the scores we measured. Here's what it looks like within that population. That gives us some understanding of that value. Cons, we're not manipulating anything. So there's nothing about relationships or causality. When you're only measuring and reporting a single variable, you can't really talk about how it relates to other variables. That's what the other types of research are. We can't manipulate things, we can't control things, so we're kind of limited with, here's what we found, we don't know what it means, but at least we now have this value.